Greetings, DEFCON. I'm Dave. And I am here to talk about short-lived BGP prefix hijacking. I'm going to probably level with you right up front. I'm kind of terrified of public speaking, and there's an awful lot of you. The last DEFCON that I was at, there was only about like 20 people. Really, it was me and about 20 other people. So I'm going to try to talk, slowly and not faint, and try not to drop F-bombs. And if I do, I'll try to drop the F-bombs really quickly.
You're doing well.
Thanks. Feels great. All right. So who the hell do I think I am? I'm Dave. Like I said, I think I covered that. I'm Dave.
Bigger font.
Hello. I wrote.
Bigger. Terrible font. We can't see it.
I thought of that. These actually are slides that are on the interweb. So if you're brave enough to use, the Wi-Fi here, you can go to skeptech.org and just sort of follow along. I can't make the fonts bigger, unfortunately.
What browser are you using?
You know what? Good damn point. Control plus. How's that? Applause. I'm pumped now. All right. We're good. Okay. So I wrote this book. It's about building Nagios infrastructures or something. I don't remember really off the top of my head, but you should buy it because I get $4. I write the monitoring column for Login Magazine if you're like a Usenix person. I actually brought some books with me. They're way over there in that black bag. So, I'll be handing them out or doing whatever. Right on? So you can find me at those places. If you see me, I'm usually lonely, so come up and talk to me. I'm much better in person, I promise. So, really what this talk is about is, in my opinion, my humble opinion, and we probably have nothing but spammers in the audience anyway, so your opinions don't count. In my opinion, I believe that we are incentivizing spammers to attack the network layer by using things like RBLs. And I'm going to give you basically some historical context around why I think this. And I'm going to then cover an attack that I think is really scary and that I would like to sort of nip in the bud by hopefully convincing you to stop using RBLs. So this is sort of the context portion of the talk. And what I have here is I have a timeline that starts in 1978 with Gary Thurek. You guys remember Gary Thurek? Does anybody know this story? Gary Thurek, a book to the first person who can tell me where Gary Thurek worked. There you go. So Gary Thurek was a sales engineer at Digital Equipment Corporation in 1978. And he had a problem, and his problem was basically that he knew a lot of people on the East Coast. He knew lots of, MIT, people, and he knew lots of Cambridge people who were into computers, but he didn't know anybody on the West Coast. And so what Gary Thurek decided he was going to do was he was going to host a couple, meet and greets basically on the West Coast so that people could come and look at the new DEC PDP-20, the DEC implementation of the PDP-20 at the time. And in order to invite them, he thought it would be neat, in digital and, net aware, if he could email every single person on the West Coast who was on ARPANET at the time and tell them, hey, we're going to have this meet and greet, come and see the PDP-20. And needless to say, it pissed a lot of people off. It's really funny. It's amusing actually because at the time, the send mail interface was like, and this is send space mail, not send mail. It was not very helpful. And so Gary, not wanting to actually do this himself, had his secretary manually type in all 600 addresses. And so and it's great. You can see this on there. You can go and look. It's hilarious. She starts in the subject line. And just, and the subject line buffer is 1 line long, so then she wraps to, 2, and then CC, and then you have this big long list of CC addresses. And then that overflows, because the CC address line was, I don't know, like 320 lines or something like that. And then it actually wraps into the body of the message. It's neat. It's kind of, sort of old school, in a way. But anyway. So the poor woman had to type in all of these addresses manually, and they sent the mail, and it only went to like half the recipients they wanted it to go to because of obviously most of the addresses were in the message body. And holy crap, did it generate some backlash. And also some other really interesting things happen, like you have these really neat emails that are coming from like RMS, Richard Stallman, who are saying things like, yeah, I guess it's kind of annoying, but if it has to do with jobs or chicks, send it to me. I'm good with that. It's out there. I'm paraphrasing, obviously, but yeah. So, and by the way, all of these dots I'm not going to spend this much time on. So, 1978, you basically have the world's first spam. So, the period between 1970 to 1994, not a lot is going on. You have a couple right there before the green card spam, right? And these are not, these are like, I love Jesus and can I, get some money for my scholarship, fund or something. I don't remember exactly what the point of that one was, but none of them were commercial and unsolicited until Cantor and Siegel. And the real difference with Cantor and Siegel is a pair of lawyers. They were eventually disbarred. Lawyers who were so despicable that even other lawyers decided they were too despicable to be lawyers anymore. And really the weird thing about them that was unprecedented at the time was that they were completely unapologetic about it. When people were spamming Usenet before this, the Usenet community would rear up and say, wow, you're spamming us. And people would say, oh my God, I'm sorry, and then go away or, learn to be polite. Cantor and Siegel were really happy with it. I mean, they were like, yeah, backlash. They wrote a book, actually, about the whole thing that sold, like, I think 4.5 copies. It's selling a little bit better than my book at this point. But they wrote a book and created a, consulting firm for guerrilla marketing on the internet. And like I said, were eventually disbarred. So between 94 and 95, this is like sort of the infantile period of the web, and people who sort of have this sense for, holy crap, that could make me a lot of money, and I have no morals, that type of, sort of intellect was, looking over at Cantor and Siegel and noticing, holy crap, there's actually probably some money to be made here. And at this point, you have the actual interweb, so to speak, and you have lots of people on it already. Most of them, like Unix shell accounts and stuff, but still, you had quite a few people you could reach with any given message. So by 95, you have, and this is just 1 year later, you have the first commercial for sale spamware, basically, for all intents and purposes. It's like a Perl script or something, but it's it's being commercially sold as software, and along with it, an email address list of 1 million people that you can, reach, supposedly. And also in this time, you have these sort of weird agencies called the Freedom Knights, and there's an acronym there that I can't remember off the top of my head. But so like there's these trade groups that are coming up that are saying, let's legitimize this as a business strategy and blah, blah, blah. And there's a lot of argument going back and forth, and a lot of it is really neat and naive and cool. It's it's like people who nowadays would be like shoot them, just shoot them, public hangings, right? It's like these people, but they're sort of on the other side. They're like, well, censorship and blah blah blah, and this is probably not a good idea. Some of you who are older might remember Cancel Moose. Cancel Moose was a guy like somewhere in the Netherlands. Who was one of the very first people who could cancel UDP postings kind of at will. And he, also, he had this sort of enigmatic, I guess a lot of you, will probably relate to this. He had, like the code name Cancel Moose. And no one knew who he was, and he was, like this shadowy, enigmatic character. And he generated a lot of discussion around this time about, just what is a netizen's right around not receiving someone else's email. So at this point, basically in my timeline, I have a split. And what I'm doing here is and you could disagree with this if you want, and you'd probably be, you'd probably have a valid point. But what I'm doing is I'm separating the anti-spam solutions into two basic groups. And the one on the top, the green dots, is content filters, right? So like this is various forms of content filter that have sort of evolved around over the years. Down here at the bottom, I have what I call delivery countermeasures, and these are solutions that are based on basically taking some indicator, right? It's IP address or email address of sender, or just some token, right, in the email, and we're going to use this singular token, and we're going to block the message. So, and in the center, I have what the spammers are doing. So you can sort of see, like right off the top of your head, what's happening down here is we have kind of an arms race going on with the delivery countermeasures. You start off with cancel moose, then you start going into like static IP and static from address filters, which cause job attacks, which beget RBL, which causes whatever open relays. There you go. And it's just sort of kind of bouncing back and forth between spammer and anti-spammer. This goes on for about 20 years at this point. This has been going on, this sort of delivery countermeasure war, and you start off and I'm assuming most of you guys know, like when I say gray listing, right? Like I see heads nodding. So when I say RBL, basically just a blacklist of IP addresses that somebody else is doing. Here you have this is around 1999. Here you have e-stamps and hash cache, and these are like e-stamps is a micropayment system, right? So like every email you send has basically a check at the bottom of it, a PayPal check, or use third-party verification of your choice type provider thing. And so you send me mail, and the mail has this little check at the bottom of it. And if I want your mail, I don't cash the check. Right, and it's like a check for 2 cents or whatever it is. But if I didn't want your mail and I think you're mean, then I cash the check, which even now seems sort of kind of silly. Hash cache was sort of the same idea, right? So we're going to take this. We're going to make a micropayment system, but instead of charging money, we're going to charge CPU cycles. So when you send me a mail, I'm going to give you some marginally difficult value to factor, and then you factor it to prove that you're who you say you are. And the idea is that spammers basically aren't going to waste the time factoring. They have too much spam to send. So then 2000 we start getting into legal stuff. We're going to sue the spammers, and we're going to sue the ISPs who aren't blocking port 25 from their customers, et cetera, et cetera. Round about 2002, in the delivery countermeasures war, you have a paper from Paul Vixie, who wrote VixieCron and a bunch of other stuff. He's a big guy. He writes a paper. It's called Repudiating Mail From. Usually I can pronounce that. And the paper is basically about, hey, we're going to take DNS and we're going to make it into this authentication mechanism, right? So now when you send me an email, I'm going to go back and I'm going to ask your DNS server, hey, DNS server, where should this person be sending mail from? And if your DNS server says that it's, someplace other than where you're actually sending it to me from, then I block your mail. This was then adopted, this idea was then adopted by AOL, Microsoft, and it's now called SPF, Sender Permitted From. It goes under a couple of the names that I can't recall off the top of my head. There's an awful lot of you out there. And it's really, really popular among, second most popular, like second largest adopter, and this is from a, damn, I can't remember the name of the company. The guy where John Graham Cummings, or the company where John Graham Cummings works. A book to the person who knows where John Graham Cummings works. No, it's like Sophos. There you go. Sophos. So Sophos comes out with a paper like a month ago, and they actually have a like a list of who is implementing SPF procedurally within their organizations. And the second second favorite, right? The second top implementer was like corporate or really corporate companies like the American Expresses and the Bank of Americas of the world. Can anybody guess who the first most popular, like who SPF is for a book? What? Shout it out there. No. Spammers. Spammers love SPF. Because basically, I mean, an entire cottage industry at this point has grown up around registering lots of domain names, right? So you have like, Domain Guard and, like all these companies that will actually just generate on the fly like 200, domain names, random, guaranteed, never generated before, names for you. And you publish a reverse lookup record for these, and you say, that makes me legitimate. Like, yay, I can send to AOL users now. So SPF is really, really popular among spammers. I love this idea. I think it's just great. SPF sort of, a lot of people are still using it actually, but not working so well. So at this point, in the delivery countermeasures game, we've sort of reverted back to RBLs, and now we have like this preponderance of them. I mean, there's like 20,000 RBLs, and regional, specific, with .co.uk addresses and things like this, and literally just thousands of them. 20,000 may be an exaggeration there. I'm prone to hyperbole. I should have mentioned that too. By contrast, if you look up here into the content filtering section, what you see is the very first content filters were probably Nancy McCullough's procmail fax, somewhere around there, sort of mid-1994, right? Where people are just sort of using, static string filters in procmail. And that sort of continues until you hit like Spam Assassin. And Spam Assassin is basically okay. And there are arguments you can make either way, Spam Assassin being a content delivery measure or a content filter. But basically the idea behind Spam Assassin was we're going to, I'm not going to bother. Then you have 1999, you have another paper from Paul Vixie. This was actually the first paper. SPF came later, but Paul Vixie wrote a paper which basically said, okay, here's what we're going to do. We're going to take all of these emails, we're going to make a fuzzy hash sum of them, and then we're going to keep a global database of fuzzy hash sums. And then every mail you get, you can just, you can generate the hash sum yourself, and you can pair it to the database, and if it's spam, you block it. This worked pretty well. There are two implementations that I'm aware of that people are using a lot right now, and that's the distributed checksumming clearinghouse and Vipel's Razor. And Vipel's Razor, the former or the latter, has been included into a lot of commercial products as well. So the idea there was, I think, a good idea. And a lot of people are still using it. It doesn't deal very well with random strings. Like if you can break the fuzzy hash sum enough so that it's a little too fuzzy, then you get mail passed. And the other weakness it has is, despite the fact that there is sort of a nascent reputation system around who gets to send mail into what's the spam database, there's definitely some database poisoning going on there, and it's sort of reducing the effectiveness of it over time, in my opinion. And this, by the way, I'm not the CEO of anything. I like mow my own lawn. I have a job, probably a lot like you guys, like a systems administrator for a web hosting company. So most of this is based on my experience, the experience of people I talk to at universities, and just various research I've done. I published a paper at Usenix in 2004 at LISA, which basically outlines some implementation work we did. So if you want to check up on me, there you go. So then finally, in 2002, we have my friend and yours, what the hell's that guy's name again? Who wrote a plan for spam for a book? Paul Graham. You can come get that whenever you want. I'll just put it here. All right, Paul Graham. Can't believe I didn't remember his name. Anyway, I'm running out of books. I better start remembering shit. Oh, sorry. Okay. So Paul Graham writes a plan for spam, and poof, we have Bayesian, naive Bayesian classifiers. And this turns out to be a pretty darn good idea. And this is now it's 2007, I believe, and we basically have a category killer for content filters now. You don't see, and when I say that, what I mean is there are better ways to do artificial intelligence and machine learning, right? I mean, there are like vector-based algorithms. There's expert systems. This is a pretty old science, right? People in 1968 were using, Bayesian learning to prove that their algorithms were superior, right? I mean, it's kind of like if you're like the artificial intelligence scientist guy, and you want to show everyone in the world that your learning algorithm is good. The first thing you do is you make sure that it can beat a Bayesian learning algorithm. It's kind of, sort of the thing it's the bar to cross, right? But what you don't see is you don't see a lot of fancy machine learning coming into spam filtration, and some of it is because it's not applicable, and others of it are because Bayesian classifiers work really well. I mean, they really, really do. And since since that initial essay, we've had a couple refinements on the technique. We've had chi-square, and you have Markov, discriminators, and you have, a couple different algorithms. You have some data cleaning, type, the Zadarsky paper on noise reduction, Bayesian noise reduction. But you don't have a naive Bayesian classifier replacement, right, at this point. And the little secret, and despite a lot of really smart people who should know better standing up at conferences and saying that Bayesian is dead, the dirty little secret of naive Bayesian classifiers is they've been here for 5 years. They haven't been beaten yet. There's no answer to them yet on the spammer side, as far as I can tell. And most of the problems that people have with them are implementation problems. So we as a sysadmin community, I think, need to look at them a lot more closely. And when I say NVC, I'm not talking about Spam Assassin. If you are thinking to yourself, "Oh, I use Spam Assassin. This guy's full of shit. Its Bayesian classifier isn't that great." That's true. Spam Assassin's Bayesian classifier is not that great. But there are really, really rigorous implementations out there that I urge you to try: BogAFilter, CRM114, and DSpam. Any one of those. Anyway, let's get to the fun part. So I guess I think I pretty much covered the conclusions. I don't think delivery countermeasures are working for us, and that's just a little something I picked up on the 10 years that they haven't been working. So I'm thinking maybe we should not use them anymore, and this is kind of why. We have some evidence that spammers are actually starting to use short-lived BGP prefix hijacking to get their mail delivered. And maybe some of you know what it is, and for those of you who do, I don't know why all of you showed up anyway. I mean, there were better talks to go to. So I'm just going to tell you what it is. So you have BGP, Border Gateway Protocol, is basically the internet protocol of choice for backbone providers to talk to each other and tell each other where a given IP prefix is. So if I'm the owner of 64.000/8, and I want you to know where it is, I'm probably speaking, BGP to you. It's a transport layer protocol, so it's actually they speak TCP, and it's a vector path protocol, which means that when I say to you, "Hey, other router, I know this prefix, and here's how you get to it," that router will actually pass the entire path. Okay, and this whole thing, and the path itself is made up of a combination of AS paths, and AS are shorthand for autonomous systems. So you have, if you can imagine, 22,000 people on the internet. Somewhere thereabouts, a couple months ago anyway. Not people, organizations that run the internet. So if you imagine the internet as sort of this cooperative entity between a lot of private networks, you have about 22,000 private networks. And you have a couple different types of people there. You have tier 1 providers, like the level 3s and the Sprints of the world. You have the tier 2 providers, who are what most people deal with as an ISP, like the AOLs and the MSNs. And then you have a whole bunch of university networks and things of that nature. And the thing about BGP is, you would think, I don't know if I don't think Dan Greer's talking here, but that whole biological diversity thing where like everybody connects to everybody else and it's all redundant and you would think that there would be a lot of redundant paths everywhere, and in fact there are. But the problem is there's an economic layer there too, right? So we're not just talking about a routing protocol and hey, if I can get to 64.0.0.0 from your router, that doesn't necessarily mean I'm going to send you my packets. the concept of this layered, right, like ISP structure where you have these tier 1s, and tier 1s are really, really big. Like level 3 owns their own transatlantic cable big. I think they own 2 of their own transatlantic cables. That's how big they are. And so if you're as big as level 3 will peer with you. And if you get level 3 to peer with you, that means that you don't have to pay them for transport on their network anymore, okay? And then so AOL pays level 3. So that means that this is a transport relationship. Thank you. You don't get a book though. I'm saving that one. I got some math coming up, I think. I'm probably, yeah. Okay. So when you think about it, if I am independently connected to 2 tier 1s, let's say I'm independently connected to like, MCI and I'm connected to level 3. And MCI has a packet that is destined for a level 3 network. They could route through me, except I'm paying them for transport, so I'm not going to be advertising that net block, right? It's just the economics of the situation. And this is called zero valley routing policy, right? So what you have is a lot of interconnected hosts, but most of them, first they prefer a customer network, then they prefer a peer, then they prefer sort of any path they can find. But that's really important, and it'll become more important later. So BGP prefix hijacks happen when I am not the owner of 64000 and I advertise it to you, okay? And so what this does is BGP, not an authenticated protocol. And there are some, there's an IETF working group out there working on it. There are various standards, all of them requiring PKI. So what are the odds of any of them actually coming into play anytime in this century? So what you have is this unauthenticated networking protocol, right? So anybody can just pop up and say, hey, I'm 0000, send me your traffic. And I actually had a really scary conversation with someone at Usenix Seco 6 who told me that a great number of governments, including our own, find this, what was the word, useful. So this isn't a new attack. It's been going on for a long time. There are papers going back decades on it. In the past, like the slide says, people used it just basically to sell IPs to other people, which is technically something you can't do. What could you do with it, right? So these ones, and there are 3 different types. Well, there's a bunch of different types. So I'm going to cover 3 of them. There's the just normal prefix hijack where you have a prefix and I advertise exactly it. There's a subdomain prefix hijack, sub-prefix hijack, something like that. The word sub is somehow involved, is my point. And you basically, because the way BGP works is less or more specific advertisements work or overwrite less specific ones unless you have like filters in place. Usually people filter at the 24 level. So if you have smaller than a 24 net block, no one's going to pay attention to you. But if you're a 24 network and you're advertising a net block that's the same, that's in someone else's 16 block, you're going to win. Okay. So if you think about it, I as a spammer, since I don't really care, right, about your net block at all, I could just, if you have like a 24, I could advertise the 8 on your 24, and you would win for everything that matters to you. You would never notice, right? So like the spammer is just, sort of up there grabbing addresses, and some of the traffic is working and some of it isn't, and the stuff that isn't is the stuff that you've allocated, right? Which is, sneaky and underhanded. That's why I like it. So what could you do with this? You could do all of those all those acronyms at the bottom of that slide. It's fun stuff. The internet in general is still a small network, right? You have like 22,000 hosts out there. So the time it takes to converge a BGP advertisement is really highly dependent on where you are in the network and who you're peered to. If you're multi-homed, it takes longer. If you're just a single, customer of a tier 1, you could get, a propagation out there in 2-3 minutes. It's fast stuff. So I mean, you could, for example, BGP, advertise a net block, DOS the RIA or whatever it is you wanted to do, and give back the IP addresses, and be gone. And no one would have any way really to know where you were, or where you were when you did it. So this is all boring router stuff. sort of helping you visualize what's going on here. So C and D are my, tier 1 providers, and I have AS42, who's my Happy OS, or Happy AS, excuse me, and he's, advertising this NetBlock 24, and then you have the evil router that comes along up here, AS666, and he advertises, the same NetBlock, and these are the routers he fools, right? So there are actually a bunch of different ways to, this is really kind of dumbing it down. There are a lot of ways to influence BGP decisions, and a lot of people who are actually trying to do mathematical models to figure out who would be, fooled in the event of a large-scale PGP or BGP hijack. Are having to say things like, well, we're just going to assume, randomly, in the absence of, shortest path and, the rest of the indicators, we're just going to, generate a random number and, hope for the best. So it's kind of up in the air. The other thing about BGP is other thing about any routing protocol at all is that different providers have implemented it differently in their systems. So you have Cisco with, these BGP characteristics, and you have Nortel with those, and it's kind of hard to predict what's actually going to happen, is my point. You can stop me if I go off on a big tangent like that again. Okay, so that last one, we're basically assuming that, AS666 is evil and it wants our, net address. But that isn't necessarily true for the case of the spammer, right? The spammer doesn't care what IP address he uses. He doesn't want yours. He doesn't give a shit. He basically just wants some IPs, right, that aren't listed on RBLs. And your IPs probably aren't listed on RBLs. Well, yeah. Never mind. So maybe, yeah, definitely doesn't want your IPs. So now we have AS66, and we moved it down to the side here. And basically what we're showing here is that if 666 moves itself around in the network, he can influence who he traps. And this is, this is a very specific example, and this is, based on path. But there is a mathematical model here, and actually Mohit Lad at UCLA has a paper called Understanding, has Understanding in the title, and then like BGP and something else. Good paper, you should read it. Just Google Mohit Lad, it's out there. But basically they actually have a mathematical model that describes how resilient a given system would be in the case of a BGP attack, and what they found was that if you are a direct customer to more than one top-tier ISP, then you can do a lot of damage, and you're highly resilient against other people's damage. So that's, if you want to be, taking over other people's networks, that's where you want to be. You want to be multi-homed to one or more tier 1 providers. So that's, if AS666 wants, more people to believe him. The problem is that AS666 really doesn't have to use anybody's IPs, right? Like, he doesn't want yours, he doesn't want mine. Why would he want anyone's at all? He could just use unallocated space that the internet registries haven't allocated yet, right? And everybody knows not a lot of that space left, right? So, yes, read XKCD. I kind of love this webcomic. So what this is a map of the internet using a fractal called a Heimdall fractal, and what it does is it preserves block space, continuous blocks of address space, right? And it is a fractal, like you could zoom in on it and it would, become all fractally, what fractals do. It's infinitely recursive or whatever. But obviously you can't do that here because it's just a JPEG. But what we're seeing here is we're seeing all the Class A networks. We're seeing all the 8 networks in the entire internet, and we're seeing who is assigned to each one. So here's two Class A networks that are assigned to that organization, DI5A. What the hell? DISA. Thank you. Anyway, so here's the math problem, and I meant to do this on the board, or I meant to do this. I'm sorry, on the plane on the way over. But that's a long story. So, and I do this every once in a while. We can take okay, imagine for a second, we have 1,000 spammers. And each spammer wants to use a single IP address a day for a year, and they never want to use the same address twice, right? So you have 364 days in a year, you have 1,000 spammers, you have 364,000 addresses, right? Each one of these blocks in green is an address space of 2 to the 24 IP addresses, right? So a book to the first person who can divide, 2 to the 24 by 365,000 and tell me how many years 1,000 spammers get out of a single net block. It's not a happy number. It's like a lot. I have no idea what the answer is, so. Somebody else verify him or something. That was a bad question to ask at DEFCON. Sorry? 42, that's a good answer. I'll take that over the real answer anyway.
So 2 to the 24th divided by 365?
365,000, yeah. Well,
About 45,864.
excellent. So close to 42. Sorry, I already gave away the book. I'd kind of be an asshole if I took it back. So there you go. You have a good 40 years, basically, that 1,000 spammers could use basically one of these squares. And there are quite a few of these squares, right? And, there's some hyperbole there, but there's not a lot. I mean, there are net blocks in there that are, RFC 1911 net blocks that you can't use, and no one will route for you. But the basic premise is, any given spammer really could just start doing whatever the hell they wanted with the IP address space, and there's not a lot we can do about it. I've talked with a lot of the the top tiers at like Nanog conferences and stuff, and they're not even considering this to be an attack yet. They're considering this to be misconfiguration, and if it's lasting for 15 minutes, they don't care. It was a temporary misconfiguration. Well, that's best case. They're considering it misconfiguration in the best case. Worst case is, hey, that's one more path to route, stuff to. That was actually a response I got from someone was, well, hey, if I have multiple paths, better for me. I'm an ISP. So yeah. So. Spammers are doing this now, and this is basically how I know they're doing it now. This is out of a paper, shamelessly stolen from a paper by Nick Feemster out of Georgia Tech. And what you're seeing here is Georgia Tech has a spam sinkhole, right? It's a 3-letter domain, and they just let it sit there and collect spam. No valid mail comes to the system. So what they're doing is they're getting the spam, and they're doing lots of text parsing on it to see what kind of stuff is happening. Eventually, one of them got the bright idea: hey, let's take our logs of what IP addresses we got spam from. Let's correlate them with the BGP prefix origin changes, and we'll see if there's any correlation between an origin change, us getting a spam, and the origin changing back. And so this is sort of the zoomed in version, and this is sort of the zoomed out version. And what you see is origin change, spam, 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 origin change back. So I mean, that's like taking a freaking snapshot. I mean, you can't really get a lot closer than that. It's happening, right? And they actually quantified this, and it's not happening an awful lot. But as we saw in the don't make me show you the time thing again. Stuff in Spammerville happens very quickly, right? So when one spammer catches on that another spammer is getting his mail delivered this way, lots of other spammers are going to eventually start doing it. It's not a threat, it's a promise. So how do you pull this off, spammers? How easy is it? What do I have to be? Where do I have to be, etc. It's actually surprisingly easy to pull off. You have to have some cache to do some real damage, right? Because you have to get right underneath a tier 1, and it's better if you're multi-homed. But you can, like the slide says, use a shady ISP, be a shady ISP, or work at a shady ISP. And there's also a lot of social engineering that you can do at that level. Like, hey, I think you're filtering my announcements, like, especially if you're multi-homed. And if you're a relatively large network and you're multi-homed, they're just going to believe what you say, right? Like, hey, I have a path to, 65, 80, whatever, right? And they're not even really, I mean, if you're like Covad, they're not going to question you. So you'd be like Covar, and then like, I don't know, whatever. Use your imagination. And they're really not focused on this attack at all. I mean, they're very much of the opinion that nobody's doing it and we don't care. So it's pretty easy to get in there. I've heard rumors, and that's in America. Going into other countries, it becomes, an awful lot easier. And it sort of depends then on, how much damage you can do. But really, I've heard rumors that there are, like Zen UML type systems in, places like China that you can get for the purpose of just making bogus BGP advertisements. I highly recommend going to Nanog and talking to, just sort of some of the profs there, because I mean they tell great stories about getting advertisements like 0000 from places like Vietnam, and some of it actually working. And yeah, I think there's a lot more of this going on than even we suspect, right? And not all for spamming. But anyway, that sort of wraps up my talk. Was that like a half an hour? Was I really fast?
42 minutes.
Excellent. And I'm out of books. So questions, comments, points of clarification? Oh. Okay. Right. So to paraphrase that, for those who couldn't hear, the question is basically, why isn't a regional internet registry able to just basically tell people, hey, that origin isn't, sorry? Okay. And there are a couple of those out there. There's actually, like, I don't know if you've heard of, why can't we get a third party? How about that? To tell us, look, here's all of the prefixes that exist, and here's where their origins should be, right? So why can't we mitigate this with, just sort of a list of, stuff? And this has actually been tried. Well, there's a couple different, like I said, there's the IETF working group that's working on stuff like that. There's also a solution called BGP. Wow, I'm amazed I said that right the first time. Which is pretty good BGP, right? Which is sort of based on that sort of thing, right? Like every time somebody gives me an advertisement, I'm going to go to this database and check. The problem is that even people who are using these, and this actually happened March 2005. Google had an outage. Maybe you remember it. And there's a paper out there by a couple guys in Canada who looked at origin changes for the Google routers while they were having this outage. Google later said that it was a DNS outage, as I recall. But they did find actually that there were some origin changes that happened during that period. And on top of that, they found routers that were, using things like filters, right? I mean, you would think you could just solve this with, this person is advertising something they're not allowed to. I'll just have that in a filter and it'll be done, right? The problem is what I was explaining to you before about the economics of BGP. You can't assume that even if you're using a filter, that the route is going to come from someone you have filtered. The other thing is that you can do things with BGP like AS path prepend, which means that you don't necessarily have to be the origin anymore. You can just sort of inject yourself into the AS path, and that'll work for you for a great number of people. I should back up and say, just sort of, conceptually, right? We're having the same problem here with spammers that we've always had in the past. And that problem is that we're assuming we can give them some token or credential, and we can expect them to not use someone else's, right? And we're also assuming that the protocols involved are robust enough to prevent them from using someone else's. And the problem really at a conceptual level is that none of that is true, and it never has been. And we really need to rethink, a lot of the underlying protocols, and, a lot of people are doing that. But like I said, a lot of them depend on things like PKI and, pipe dreams. Anyway. Questions, comments, points of clarification? It's a good question, by the way. Yes, in the middle.
What about Rogan and Martian filters? Are most major ISPs still not filtering out unallocated space entirely?
I didn't quite catch it.
I asked, what about Rogan and Martian filters? If most tier ones aren't filtering out unused and unallocated space?
Right, yeah, okay, so like RFC 1911 space. Just unallocated space in general, right. To my knowledge, they aren't. Obviously, because this is working, they aren't. I think that, and that's, by the way, totally where I don't want to go, guys, right? Like, that's the whole point that I'm here giving this talk. I don't want to blacklist unallocated IP space, right? I mean, I understand that's the next logical step in the, right, and there is actually a maps RBL that does this. There's a maps RBL that your Cisco router can consume that will actually, you know, if it's, you know, not valid IP address space that, as defined by the maps RBL, then we won't route it, right? And that scares the crap out of me. Like, I don't want to live in that world, and that's so totally why I'm here. But also, yeah, I don't think it's logistically feasible at this point, because, you know, there's sort of a decentralized nature, to, right, like, this, 1 second. So let's say I'm the RIR, and I give a whole bunch of unallocated space to, you know, level 3, and let's say level 3 doesn't use it for 4 years, right? Like, then what do you do? And then you have the problem with that same solution also. What happens when IPv6 gets big and you have spammers that are either, well, what happens until IPv6 gets big and you have spammers hiding behind IPv4, you know, NAT boxes, or after IPv6 gets big and you have spammers hiding behind IPv4, you know, legacy boxes, right? So then what are you going to do? Are you going to say, well, if it's coming from the entire IPv6 network, I don't accept their mail? I think there are some really scary places we can go, and I'd really appreciate not going there. So I'm getting the 5-minute warning, and I want to give the next speaker some time, but I understand I'm being taken to a question and answer room. Sounded ominous to me. So I'll meet you guys there if you guys want to come. Oh, which room am I going to? 109.